So your supermarket sells two different types of apples, Granny Smith and Fuji, and then we want the masses in grams of each type of apples follows the normal distribution. The mean and standard deviation of this distribution are shown in the table. So 150 is the mean for Granny Smith, standard deviation is 11.7. For Fuji Smith, the mean is 180, the standard deviation is 15.2. Then two Fuji apples are chosen, and we want to find the probability that their masses differ by at least 20 grams. Right. So first thing, what do we need to do? We need to first always define the variable. Right. So we will say maybe let G. Right. So let G be the random variable denoting the mass in grams of an apple at Granny Smith. So you always remember that you need to define your variables. Let f be the random variable denoting the mass in grams of an apple at Fuji. Okay. Then we're going to find the probability that the masses differ by at least 20 grams. So we don't know who the fact is we don't know who is the lighter one, who's heavier. But the fact is it could be Granny that's heavier, or it could be the first Fuji apple that's heavier, or second Fuji apple. So how do we deal with a question like so? If we read this, you know that like you're going to find the absolute difference to be at least 20 grams. So it suggests that what do you need? You need a modulus. It will be 11.7 square times 2 to find the Granny Smith apples are sold at $3.50 per kilogram, and Fuji apples. So now we are computing probability based on cost. Alright, so I'm looking at 6 Granny Smith apples. They have a certain cost per kilograms. So another thing that might trick people is that here they are looking at kilograms, but remember the question was in terms of grams. So we need to do the appropriate conversion. Alright, Fuji apples are $5 per kilograms. So 4 Fuji apples, $5 per kilograms, they follow this normal distribution. Granny Smith 6, $3.50 per kilogram, follow this distribution. We need to do a normal distribution that encompasses the cost of six Granny apples, Smith apples, and 4 Fuji apples. Given that this costs $3.50 per kilogram, this costs 5 kilograms. So first, let's get our facts right. 150 and 11. So question 1. The cost should not probably that the cost more than 6.5. In here, we're actually talking about the probability that have the modulus of f1 minus f2 to be the difference to be as greater than 20 grams. Right? Next, what do we need? We will need to know find the parameters for f1 minus f2. f1 minus f2, right? Very quickly we can compute the parameters at the side. And this will just be 0 and 2 times of 1.5, and if we go, so 2 times of 11.7 square, right? So very quickly we can write this down. So probability, okay, again just like how we did in question 5 earlier, we just split this up. Right, they may not be equal, just to say that they need not be equal, but this is always true, right? These two may not be equal. In the earlier question it was equal because the mean was 0, right? So here it's different, right? So with that, quickly, here this is just 2 times, okay, 0.17608 10402. So why is it equal in this case? Because again the mean is 0, right? So because this is basically because the mean is 0, if we think about it, when the mean is 0, then this is how your this is okay, just ignore this part. How f1 minus f2 look like. 20 could be somewhere here, minus 20 will be somewhere here, so therefore they are actually equal. can see that the probability are actually equal, right? The probability of F1 minus F2 less than -20, right? The probability of F1 minus F2 greater than 20, they're actually equal. Okay, that's why I just take 2 times of the answer. And my answer comes out to be 0.352. Alright, and next, part 2. I need to part 2, right? Let's get off 7. So basically, part 2, the Granny Smith, right, takes on the normal distribution. Okay, the Granny Smith, right, takes on the normal distribution of how many grams? This way, okay, 150 and 11.7 square. Alright, so if you were to talk about dividing them by 1000, remember this is in terms of grams, this is in terms of grams, which is kilograms. So G1 plus G2 plus G3 plus total we have, remember we have 6 Granny Smith apples. Take a normal distribution of 150 times 6, so it's 900 grams. 900 grams will be actually 0.9 kilograms. Right, so same thing, 11.7 square. Right, this in terms of gram. If we multiply it by 6, we're going to divide it by 1000, and answer, I'm going to just write it here. It's just 8.2134 times 10 to the power -4. Okay, this would be the normal distribution for that 6 granny apples, right, in terms of kilograms. This is in terms of kilograms, right? And when we talk about the slowly I'm going to convert that. We know the Granny Smith apples cost $3.50 per kilogram, so I'm going to put $3.50, right, multiplied by G1 plus G2, right? So what I'm going to do next, I'm going to find the parameters that represent the cost of the 6 Granny Smith apples. Alright, so $3.50 here, it means I'm going to take 0.9, I'm going to multiply it by 3.5, I'm going to get 3.15. I'm going to take my variance as well, I'm going to multiply by 3.5 or 3.5, no, we're going to multiply by 3.5 square. Okay, so remember that 3.5 of variance 3.5x, right? So it equals to 3.5 square of variance x. So mainly we're going to take 3.5 square multiplied by this number to give us a 0.010061415. And next we have the Fuji apples, so there are 4. So again, they are in terms of grams, we're going to convert them, right? So you just do the conversion yourself. I'm sure you can get it, right? You get 0.72 and 0.092416. Okay, and again, I know that the Fuji apples cost $5 per kilogram, so I'm gonna take it multiplied by 5. So this already I'm done doing in terms of kilograms, right? I already converted. Okay, I skip a few steps, and 5 times of F1 plus F2 plus F3 plus F4, right? The normal distribution again. I'll take 5 times of 0.72 or 3.6, and here remember we need to square. When we multiply the scalar in, we have to square it, right? So 5 square multiplied by this, right? So just like following this, right? Okay, so variance of 5x will be 5 square variance x. So this will be 5 square of variance x. That gives us 5 square multiplied by this number here to be 0.023104. And finally, right, I have my Granny Smith apple settled, the cost. I have my Fuji cost settled, and now I'm going to add these two together. So I'm going to say maybe let t, oh sorry, not good, let t be the random variable denoting the cost of 6 Granny Smith apples and 4 Fuji Smith apples. Alright, and after that T will take on a normal distribution. So basically what I'm going to do next, I'm going to add N1 like this and this, right? So with that I'm going to have basically I'm just going to add, because I'm adding up all the cost of 6 Granny Smith and 4, so I'm adding this and this, okay? And that should give me a total of 6.75. Same thing, I'm going to add a variance. That gives me 0.033165415. Basically, we need to find, the question requires to find that the total weight should be more than 6. The cost should be what? 90, should be more than 6.5, right? And so use a GC for this, and you get your answer to be 0.915087729. Approximately, it will just be 0.915. Okay. And of course, the third part, what do you assume? Of course, we need to assume very easily. We need to assume that what? You can actually think about it yourself, right? Okay, I hope I leave the part 3 to you. That's a very important assumption you need to do in order to assume that there's independence, alright?